Good afternoon, everyone. This is I'm Rudrashen. I'm a PhD scholar from IIT Delhi, and I'll be the TA for next 8 weeks of this course, which is a basic linear algebra. So today we will discuss about the solution of linear equations. Okay. So first of all, uh, if we consider a system of equations, if we consider a system of equations in R2, so R2 says this R means, so this R means like real number and 2 means the dimension. So let's say we have an equation something like this, x minus 2y equals to 1 and 3x plus 2y equals to 11. So we can write it in a this matrix vector format, which is something so this is the matrix and this is the variables that we are basically try to find out, and this is the vector. So if we see the row picture, now row picture means if we see the particular this equation, so we can write that x minus 2y equals to 1, this equation, the graph of this equation is something like that, and the 3x plus 2y equals to 11, the graph of this equation something like this. So this is in xy in two dimension. So we know that there is the intersection of these two lines, so we have a solution. So this is basically the row picture. Now you can see the column picture of this equations. The column picture is something like that. So let me write. So here again, the equation is, I'm considering the equation is same equation I've considered. So this matrix is known as a coefficient matrix, as I said before. So we know that the first first column vector is multiplied with x, and the second column vector is multiplied with y. So we can write this above equation something like this format. So if we see the column picture, so in geometrical approach, so you can see that that 2 minus 2. So this is basically minus 2 2. So the vector is something looks like this. Okay, and this is 1 3. So we have studied in as you have already studied in mm, +2 levels, like the addition of the addition of the resultant vector, the vector addition that we have studied in already in +2 format. So it would be this, something like this, and this is basically the resultant vector, which is 1 and 11. Now, how this is basically come up? So if this is the sorry, so so if this is the so if this one is the column format of this equation. Now we know that if we multiply the first column with 3, now if we multiply the first column with 3 and the second column with 1, we will get 111. That means what we are basically doing, or what we are basically doing over here, we basically expand this vector. We are basically expanding. So we are basically expanding the vector, that column vector 1 3 by 3 times. So this column vector, this expanded column vector, which is basically this one, basically 3 and 9. So 3 9, and the resultant vector that you will get the 111. So here I am showing it over here that a geometrical. So we are basically doing the solution analytically. So here we are basically giving you the geometrical picture how this system of equations gives us a solution. Now, if we know that when the two or many lines in 2 dimension, or in 3 dimension, or if two or many planes are uh, intersecting with each other, then we get the solution. If they are not intersecting, that means there is, I mean, no, there is no solution. Like uh, two parallel lines. In case of two parallel lines, if we see, like they are not intersecting with each other. Okay, so in that case, we will get either no solutions or many solutions, something. So let's take an example. And another thing that basically you can see over here, let's say we have a the set of system equations in 3 dimensions. Okay, so this set of, so we can write it in a matrix vector format. Okay, so in this matrix vector format, if we see, if we exchange the row, we exchange the row, like if we exchange the row between let's say we are exchanging the row 2 with the row 3. So our solution is so the systems looks like the matrix is looks like that matrix is basically changing. So you may think of like the we get a different solution, but it is not. Exchange of row or multiplication of scalar, then addition with the multiplication of a row by a scalar, and then addition with another row, addition or subtraction with another row, does not change the system of the solution of the system of equations. So basically here exchanging of row does not make any effect on the system solution. Okay. So now here we will be basically studying the Gauss elimination. We'll be basically discussing about the Gauss elimination method or and echelon matrix. So this basically easier for this basically so what is the need of this elimination method, Gauss elimination method? Because or this echelon format of a matrix. What is the need of that? So it basically makes the system it basically easier for us to find out the solution of a system. Uh, so in case of 2 by 2 or 3 by 3 matrix, it is very much easy to calculate. But when we move to from 3 dimension to a higher dimension, let's say there's a 10 by 10, there's a 10 equation and 10 variables. So for that case, by hand calculation is a little bit difficult. Sorry, a little bit difficult for us. So in that case, uh, this type of row elimination method help us to find out the solution. So what is the what is basically the what does the row elimination method does? What basically the row elimination method does? So first of all, tell me about what is echelon matrix. So sometimes it is called echelon matrix based on that how someone pronounce it. So the format of the echelon matrix is something like upper triangular. Means all the zeros lies in the lower portion of the triangular matrix. Okay, all these are lies in the lower portion of triangular matrix. So let's say if the first element of the first row is non-zero, forget about the other element of the first row. If the first element of the first row is non-zero, that means all the element below all the elements below that first element of the first row should be zero. So the next non-zero element of the next row should come after the first column. So that means, so if something like, so here star signifies the non-zero element. So if something like I have a some matrix like non-zero element in first and second column and fourth column, third column is zero. So to make it an echelon matrix, it in the second row, the first non-zero element should start from second column, not from the first column. The first column always should be zero. From the second column, the first non-zero element of the second row should start. It may start from the third column as well. So if it starts from the third column, then in the third row, the next non-zero element should lie in the fourth column. So in that case, that means the first non-zero element, the element below the first non-zero element of a particular row should always be zero. This should be the happen. Okay. If it is not, then it is not considered as an echelon matrix. So let's say we have a matrix Ax equals to, we have a equations, linear equation like Ax equals to B. Okay. So Ax equals to B is a linear equation. Now we augment this. We attach the B column with the B vector with the A matrix, and we get something like this picture. Okay. So let's try with this previous example. So if say, let's say if we have a something, let's say we have after row elimination method, let's say after Gauss elimination method, we have this kind of echelon format of the matrix. Okay. So here we can see that the last zero of the A element, A matrix is all zero, but the last element of the B vector is non-zero. That means this is something come up with this kind of solution, 0 equals to non-zero element, which is basically wrong. That means this system of equations is inconsistent. That means we will never get any kind of solution from this system of equation. Okay. Now, if the same thing, let's say all the same things is equal like this, and the last row of this augmented vectors after row elimination method is come up with something like that. So that means it is become 0 equals to 0. That means the system is 0. So 0 equals to 0, that means consistent. System is consistent. That means we will get at least a result. We will get a result of this. We will get a solution from this system of equation. It's not necessarily unique solution. It's not necessarily a many solution. I'm not talking about that. This is basically, I'm saying that we will get at least a solution. Okay. Now start with an example. So here basically is just the first example is here. You have a system of equations, something like that. X plus 3y plus 5z equals to 4. X plus 2y minus 3z equals to 5. 2x plus 5y plus 2z equals to 8. So this is the system of equation. Okay. So what we do, we convert it into a matrix vector format. So something like that. So we put all the coefficients of the equations, all the coefficients in a one matrix. This is basically the variables that we have to find out the value of the x, y, z, that is the solution of the equation. And this is the b vector. Okay. Now, what is the next approach? The next step is we augment this b vector with the a matrix. So we will get this kind of thing. Okay. So now we do the row elimination method. So as we have seen, as we can see basically here in the first element, the first row of this matrix is augmented matrix. As we can see that all are non-zero. Specifically, the first element, specifically that first element is non-zero. That means we do not need to exchange any row. I mean, we do not need to exchange the rows. Okay, but we want that all the element below this first element should be 0. All the element below this first element should be 0, right? So what should be the output? The first row operation would be, we want to change the row 2 to make it a 0. The first element should be 0. So row 2 equals to row 2 minus row 1. And the next we want to change row 3 as well. So row 3 equals to row 3 minus 2 row 1. Okay. So after doing this thing, what we get? First row is unchanged. Second row is something like 0, minus 1, minus 8, and 1. And the third row is 0, minus 1, minus 8, and 0. Okay. Now, again, we get a pivot element. So these are called pivot element. What is pivot element? Pivot element means the first non-zero element of a row which basically involved in row operation. Those elements are called pivot elements. Okay. So this is the pivot element for first row. This is the pivot element for second row. Okay. So what is called? It is a pivot element. This is a pivot element. Okay. So what is basically so we need to make this element to 0. Then we will get the echelon format, right? So what we do the next operation, that is we need to change the row 3, which is a row 3 is basically the next new row 3 will be row 3 minus row 2. So after doing this row operation, what we get something like 0 equals to minus 1. That means this system of equation does not have any solution. It is inconsistent. That means system has no solution. Okay. Now do the next example. So here we have considered a 3D picture basically. So the 3 equations and 3 variables. So 2x plus 4y minus 2z equals to 2, 4x plus 9y minus 3z equals to 8, minus 2x minus 3y plus 7z equals to 10. Again, we do this, we convert it into a matrix vector format, that is ax equals to b format. Okay. So the next step would be just augment this b vector with the A matrix. So this is basically this kind of thing. A, A, this is basically the matrix A, and this is vector B. So this is, and then we do the row operation. So first row operation, what is our approach? We do not need any, first we have to check whether any row exchange is required or not. If it doesn't require, so don't do it. Sometimes it is required to, sometimes row exchange will be helpful if for calculation, then you can do it. But keep in mind that whenever you choose the first row, it has to be like the first element of the first row should be 1, or the first should be, not should be 1, the first element of the first row should be non-zero. If it is not possible, something, if you have something like matrix, something like let me write it as a right. So let me, if something you have a matrix something like 0 1 3 0 minus 5 2 and 0 3 5, let's say this is your matrix. So it is not possible, in any case it is not possible for to make the matrix the first element of the first row to 1. So in that case, of what will be the first non-zero element? So this is basically the first non-zero element of first row. So keep it that way. Make these two 0. Okay, make these two 0, and then the second element, if after making these two 0, then the second non-zero element would be in here. Okay, so if second non-zero will be here, then this row should be 0. If it is not 0, then it is not possible to have an echelon form. Okay, mostly every m cross n matrix we can convert it into an echelon form. Okay, so this is just an example. I'm trying to just explain myself. Yeah. So here, what we do, our first operation. So we need to change we need to make these two elements 0. So for that, we have to change the row 2. That means row 2 minus 2 row R1. We will get, we can make this term to 0, and then we have to change these things. So what will be that? Row 3, new row 3 would be R3 plus R1. So therefore, we get unchanged row 1, then change row 2 and row 3. Okay, after that, so this is basically the pivot element for first row, this is basically the pivot element for second row. Now we have to make this term also 0 to make it an echelon form. So to make this echelon form, what is the next approach? We need to change R3. So R3 should be R3 minus R2. Okay, so we will get this augmented matrix form. So this, what it represents? It represents something like this equation, which is 2x plus 4y minus 2z equals to 2, y plus z equals to 4, and 4z equals to 8. So from here, what we get? We get z equals to 2. This is the back substitution method. So first we put the value of z. We get, first we find out the value of z. After getting the value of z, we put the value of z over here. We get the value of y, and after getting the value of y, we get the value of z and y. Over here, we get the value of x. Okay, so this is z equals to 2, y equals to 2, and x equals to minus 1. Now comes to the um, like this is basically the approach. When there is a MATLAB command, we know. If you don't know, just I just may give you the information. Like there is a MATLAB command called RREF. Using that MATLAB command, we can make reduce echelon form actually. But so row reduce echelon form we can find out. So that means first here in this week, in this class, in this discussion, we are talking about a row echelon form. In the next class, we will talk about the reduced row echelon form or row reduced echelon form, whatever. So MATLAB, there is a command RREF. which basically does that row reduce echelon form. So how MATLAB or this language basically works, how they do this whole thing. So basically something, so we know that there is an identity matrix where all the diagonal elements are 1 and off diagonal elements all are 0. Now there is a called permutation matrix. Permutation matrix basically the exchanged row of identity matrix. Okay. What does it mean? It means that let's say if we want to exchange the row 1 and row 2 of a final of any matrix, if we want to exchange the row 1 and row 2 of any matrix, we need to multiply that matrix. We need to pre-multiply that matrix by this matrix. Okay. So this is basically we just exchange the row of identity matrix 1 and 2. We just exchanging the row of identity matrix 1 and 2. So that's why we called it a P12 or P21, whatever. We are basically exchanging. Now let's say we need to exchange the exchange of a matrix. We need to exchange row 3 and row 1 of a particular matrix. So this should be the thing. Like the row 3 goes over here into row 1 and row 1 goes down to row 3. So this is the thing. So let me explain these things using some example. So the question is, what 3 cross 3 matrix, I call it as E21. We need to find out the matrix E21 which subtract 4 times row 1 from row 2. That means we need to find a matrix which multiply with the specified any matrix where we can subtract 4 times row 1 from row 2. Okay. So the matrix format is something like that. So we do not need to change any row 1 because we do not say that row 1 needs to be changed. Okay. So that's why 100 is there. First row should be 100. Now in the next row, what is the thing? We need to subtract 4 times row 1. That means we need to multiply by scalar 4. We need to multiply by the scalar term 4 with row 1 from row 2. Row 2, there is no multiplication. That means we need to multiply by 1 row 2 and we need a subtraction. So minus 4, 1, 0. And there is a no change in row 3. So it is 0, 0, 1. So again, I'm going to take the previous matrix. Okay, that matrix that I have considered over here, this matrix I have considered over here. So I'm going to take that matrix just to show the operation and pre-multiply that matrix by E21. So this is E21 and pre-multiply this A matrix by E21. So what we get? We get that since 100 is over here in the row 1, that means row 1 is unchanged, right? Every time row 1 is unchanged because this is the multiplication process, right? Row 1 is unchanged. Row 2, what the row 2 we get? Row 2 is basically R2 minus 4 R1. If you see 4 multiplied with this 2 and then we subtract from 4, we will get, so this is basically the changed row 2. And again, we do not need to change the R3 because we do not say anything about R3. That means R3 is unchanged, R3 remain unchanged. So this is the unchanged R3. So this is how basically MATLAB do the row operations. When we do the RREF command, MATLAB basically do this kind of operation. So this is basically the operation that we are doing by hand and MATLAB doing by some kind of, it generates this kind of matrix and pre-multiply with something. Okay. So here again, I'm just to make you clear, I'm just going to give you, I'm going to present another example over here. So the example is something like that. So here we have 3 equations and 3 unknowns. Okay. So that is x plus 2y plus 2z equals to 1. The first equation. Second equation is 4x plus 8y plus 9z equals to 3. And the third equation is 3y plus 2z equals to 1. Okay, so we have this equation, and there are two uh, defined matrices. The first one is a permutation matrix that I have already mentioned over here, and the second one is again that row operation matrix, that subtraction, addition, and multiplication, scalar multiplication matrix. Okay, I called it P32. That means we need to exchange row 3 and row 2, and there is a E21 over here. So the question says apply E21 and then apply P32 to reach a triangular system. That means we need some kind of system where it did not say anything about upper triangular or lower triangular. So we need some kind of systems where almost the diagonal element is non-zero and one half of the diagonal should be zero. This kind of structure. So I just skip one step here. So I just already augmented this matrix. So find first you find out the coefficient matrix, and this is the B vector, and then augment it. So this is basically the A matrix, this is basically the B vector, and I augment it over here. So this is basically the A augment B. Now I call it a G. Now I multiply this A augment B, multiply this A augment B by E21, okay, and call it as G. So what it happened? So if we multiply E21, if we multiply E21 to AB, this augment matrix, we will get something called this matrix, where you can see that the second row is basically row 2 minus 4 row 1. That the first row is unchanged and the second row is also unchanged. First row and second row unchanged, but first row and third row unchanged, sorry, and the second row is changed to R2 minus 4 1. So this operation is applied over here. So you can see, so this is G matrix, and so what it say, first apply E21. So here I have first apply E21 and then apply P32. So after applying P32, what we get? We get so P32. What does P32? Basically, it exchange the row 3 and row 2. So we basically exchange this row 3 and row 2. So we will get this kind of picture. So basically, this is kind of triangular kind of structure of a matrix. So this is, you can call it as an echelon matrix, because you can see the elements below the pivot elements are all zero. Elements below the pivot elements are all zero. So you can call it as an echelon matrix. Now, so here in this case, definitely we do first operation, we do multiply. What we did multiply E21 first. After getting the result, we multiply P32. That means we first do that scalar multiplication and subtraction of rows of matrix A, and then we exchange the rows. So now what will happen? What would happen if we apply P32 to E21 at once? That means we first, here you can see P32 E21 AB. I am doing it at once, not one after another. I'm doing it at once. So what does it mean? So P32 first, what does P32? What basically P32 does? It basically first change the row of it first basically change the row of E21, and you can see that row has been changed. Row 3 and row 2 has been changed in E21, and then this changed E21 is multiplied with A, and you will get the same result. Basically, both give the same result, whether you apply it at once or apply or do it one after another. So here in previous case, we first do the row operation. We first multiplied this row 1 by scalar 4, and then subtract it from row 2, and then after that, after getting this result, we exchange the row. But here what we did, we we basically first exchange the row of the E21 matrix and then do the row operation. So this is basically something. So we get the same result. This is just verification purpose. Whether we'll get a different result or not, that's verification purpose. So The purpose of showing these things is basically how MATLAB does this kind of things, how MATLAB does this kind of operation. So MATLAB basically generates, when this RLF command is applied to particular matrix, MATLAB basically generates this kind of matrix and gives us the row echelon format. Okay. So internally, these kind of things happen. Now, comes to the next example. So what next example shows? So it is basically, again, we have a three systems of equation and we have a three variables. The first equation is x plus 4y minus 2z equals to 1. Okay. Second equation is x plus 7y minus 6z equals to 6. And third equation is 3y plus rz equals to t. Okay. So here r and t are the unknown variables as well. But these are not the system variables. These are the coefficients. Okay. So these are the coefficients whose values are unknown to us. Right. So the question says which number r and t, which numbers of r and t, what would be the value of r and t which make the system singular. Singular means inconsistent. We do not get any kind of result from this. So what will be our approach? First, we make this systems of make the system of equation into a matrix vector format. So we will get this kind of picture. Okay. So now the next step is we augment the B vector with a matrix. We get, this is the matrix. Then we do the Gauss elimination method. We do that process to make that matrix echelon. Okay. So first we can see that there is no need of row exchange because already we have a non-zero element at first of row 1. So we need to make these two elements as 0. So we can see that already the first element of row 3 is 0. So there is, at first there is no need to change row 3. So we need to change row 2. So what would be the operation? So new row 2, so row 2 prime is equals to row 2 minus row 1. Right. So we need to row 2 minus row 1. We get this kind of new row. Now after getting this new row, after getting this new format of matrix, we need another operation because we get the pivot element over here. So we have to make this element to 0 so that our matrix become an echelon matrix. To make this term is 0, we have to change the row 3. So row 3, new row 3 prime is equals to, should be R3 minus R2. After this, what did we get? We get this kind of structure. So now, if the system, if the value of r equals to -4 and t equals to 5, if we choose this r equals to -4 and t equals to 5, we get 0 equals to 0 kind of structure. That means this system has some solution. There exists some solution. I'm not talking about one solution or many solution. I'm talking about this system has some solution. Okay. Now, what was our question? Our question was what values of r and t make the system singular? Means what values of r and t make the system inconsistent, that we do not get any kind of solution. So that means if we choose r equals to -4, we choose r equals to same like this, and t anything, the value of t anything but 5. We do not want to choose t equals to 5, but anything. If we do this, that means we get something 0 equals to star, this kind of structure. That means this system has no solution. That means the system is singular. Now, then if we choose r equals to -4 and t equals to 5, we get this kind of structure. Okay, that means we have two equations and three unknown. We have two equations and three unknown. X, Y, Z, these three are unknown, but we have two equations. So that means we have more than we can have more than one solution. Means if we put z equals to 0, based on that we have some y, and put the value of y and z, we will get x. Let's say if we put z equals to 1, we have some y. For z equals to 1, we have some another y. If we put that value of y and z over here, we get another x. Similarly, if we put z equals to -1, we get another y, and put that value of y and z to the first equation, we get another x. That means we have more than one solution. There does not exist an unique solution, right? Now, for the same system, the next question basically, for the same system, we need to find the solution that has z equals to 1. So here I have already said that, okay, I'm giving you the value of z equals to 1. Now give me the value of, find out the value of x and y. So obviously z equals to 1. If z equals to 1, we get y equals to 3 from here. And if y equals to 3, so we get x equals to -9. So this is basically our solution. This is basically our one solution corresponding z equals to 1. Okay. So now next, let me next I have another question. Okay. So here basically we are doing some sort of variety of questions so that we get to know how this Gauss elimination method, how this echelon form, echelon matrices help us to find out the solution of the system equation, or help us to find out whether the system has any solution, system has no solution, what I mean, those things. Okay, for that case, here's the next question. So the what next question says. So here basically says that, so there's an amount of 65,000 is invested in three bonds at a rate of 6%, 8%, and 10% per annum respectively. Okay. So the total annual income is 4,800. Total annual income means that interest that comes per annually is basically 4,800. So the income from the third bond, the next statement says the income from the third bond is 600 more than the second bond. So determine the price of each bond. So there are three conditions that that is given to us. The first condition is total amount invested on in three bonds is 65,000. Second condition, that at 6%, 8%, and 10% rate, that is for each bonds, we get the annual income is 4,800. And the third information is the third bond, the income from third bond is 600 more than the income of the second bond. Is the third information. So from these three information, we get three equations, and then we put it in a Ax equals to B format, and then we do the Gauss elimination method, and then we'll get the result. Okay. So as usual, like let's say x is the price of the first bond, y is the price of the second bond, and z is the price of the third bond. So x plus y plus z is basically 65,000. This is equation number 1. Next equation is 6% of x, so 0.06x plus 8% of y, 0.08y plus 10% of z, 0.1z is equal to 4,800. We make it in a whole number, so 6x plus 8y plus 10z equals to this term, which is equation number 2. And the third equation, it says the third bond is 600 rupees 600 more than the second bond. So the third bond, that is 0.1z, the income from the third bond, that is 0.1z, is 600 more than the second bond. That means 10z minus 8y equal to 60,000. So I just rearrange this equation. So this is equation number 3. Okay. Now I put it in a Ax equals to B format. So this is basically the Ax equals to B. Now you have to do the Gauss elimination method. I'm not doing it because this is, I mean, just you have to make this term 0, and then you will get a pivot element somewhere here. And then after getting the pivot element for second row, because already you have a pivot element for the first row, so you do not need to row exchange. We need to make this term to 0, this term already 0. So we do not need to do at first with row 3. first we have to this row 2 operation. Then after getting the pivot element for row 2, we need to do the row 3 operation, and then we will get x, y, and z. I'm not doing it. I mean, you can do it by your own as a homework basically. Okay. So I think this is up to this point. You are basically okay with, right? There is nothing. I mean, uh, what do you say? There is nothing uh, difficult about this. Yeah. So if there is any question, you can ask in uh, you can ask on the forum where you basically ask for questions. So the next example is something like that. So a boy walking along the path. Path is something mentioned, something like this, like some sort of uh, uh, a polynomial path. Okay, a quadratic path, quadratic polynomial path. To this point, minus 6, 8, minus 12, minus 2, minus 12, and 3, 8. So the path passes through this point. The boy has chosen this weird type of path, which is basically quadratic polynomial path, and it passes through these 3 points, minus 6, 8, minus 2, minus 12, and 3, 8. So he wants to meet his friend at point 7, 60. So this is the coordinate point where his friend basically waiting for him. So the question is, will he meet his friend? Is it possible for them to, for that person, for that boy to meet his friend or not? Okay. So let me start with the, so let me write down the, so here basically the path of the path that boy has chosen. Okay, this is the quadratic polynomial path. Then this is the P1, this is P2, this is P3, and this is basically the P final. So where basically he is going to meet his friend. Okay. So now put the value of y and x's, we'll get some kind of, so we need to find out the value of a, b, and c. These are the coefficient of the path. We need to find out the value of a, b, c. So here, basically we need to put the value of y and x's over here. We'll get this first equation. Put the value of xy of the first point, we get this equation. Put the value of x and y in the in that path equation, we get the second equation. Okay, we get this second equation, and similarly you put the value of x and y in that path equation, we get the third equation. Okay, so after getting this three equation, what is our approach? We get this ax equals to b format. Now we augment it, a augment b. Okay, so here I have tried, I mean, just because of the calculation purpose. So it is not required to exchange row because already that first element is non-zero. So it's not required to exchange the row, but I have done it just to make these things easier. So this should be this should be row 2. Yeah, this should be row 2. We are basically exchanging row 2 with row 1. So this kind of thing. And after that, you can do the row operation. You will get some kind of result. So here I have done this solution using MATLAB. So this is basically the MATLAB, using MATLAB, as I've already told you that there is a RREF command in MATLAB. So I have solved this equation using RREF just to reduce the computation time. So RREF basically the reduced form of REF. Okay, reduced form of REF is basically the RREF. Okay, so we get this kind of equation. So from here we can see, you can see that C equals to minus 10, B equals to 3, and a equals to 1. So that means the equation of path is something like y is equal to x square plus 3x minus 10. So this is basically the equation of path that boy has chosen to meet his friend. Now you have to check the point where the boy, his friend is basically waiting, that is 760, whether we will get, whether that x and y value, that point satisfies this equation or not. That means if we put the value of x over here, it will get the same y as the coordinate point. So this is basically the PF. Now we put the value of x over here, that is 7. So we get that 60, which is basically the value of y coordinate. That means that boy will be able to meet his friend at that point. Okay, so that means this equation satisfied. That means that boy, if the boy chooses this path and follow the particular coordinates, it can he will be able to meet his friend at the particular coordinate point. So this is basically the these two questions basically shows that how linear algebra basically used in our real life application. Okay. So up to that point, I hope there is no questions, right? So I think so in that case, if you see like all those since here we are basically talking about Gauss elimination method and echelon form. So what the Gauss elimination method and echelon form does? It basically reduce the computation complexity, and it is basically makes things easier to find out the solution of the system, or it is basically help it basically helps us to find whether the system of equation has any solution or not. Sometimes it is not. Uh, I mean, geometrical approach is only be possible if we are talking up to 3 dimension. Yes, but beyond 3 dimension, the geometrical approach is not possible because we are not able to visualize something. So in that cases, we need some or we need to come up with some kind of analytical solution which shows that okay, these kind of things happen. So this Gauss elimination method and reduce row echelon form, these all are basically helps us to find out the existence of solution of a system of equations, existence or the solution is unique, or there is a many solution. This sort of things helps us to find out. Now, as you can see, like in that geometrical approach, like as I've already mentioned that this echelon form is basically we can, and you have already seen many examples over here that this echelon form we can find the echelon form of any matrix. It's not required that matrix should be a square matrix. It could be a rectangular matrix. Rectangular matrix means it could be, and the number of rows could be greater than number of columns, or number of columns could be greater than of number of rows. So in both cases, we can find out the echelon matrix. But obviously, in case of square matrix, it is very much easier for us to, I mean, in case of square matrix, it is mostly we get either solutions. You will definitely consider, you will see that whether many solution exist or not. The condition of many solution, condition of no solutions, or condition of unique solution, you will see when you will get to know about more things. So let me keep those things for let me keep those things to that level. Okay, and now next is thing is Basically, yeah. So here, so this is that if you see this kind of matrix, as I have already mentioned, this is not REF. Not REF means this is not row echelon format. Okay, because we can see that as the row echelon form we know, it should be the matrix should be the triangular matrix. Okay, that means if the elements below the pivot elements always zero. So here we can see the element below the pivot elements is not zero, are not elements below the pivot elements are not zero. That means this is not row echelon form. We can make it an echelon form definitely, but this matrix right now is not row echelon form. Similarly, this matrix here we can see that obviously the pivot elements below the pivot element are zero. But here in the second case, element below the pivot element is not zero. That means this is also not in row echelon form. Similarly, if we have something like, let's say, the matrix, like definitely that diagonal matrix, this is definitely row echelon format. This is definitely in row echelon format, right? The identity matrix. Or something like, I'm not giving any particular number, I'm just using star to represent that number is non-zero. So this is also not in row echelon form. This is also not in row echelon form. But if we convert this matrix, or if this matrix, if we say this matrix, this is an row echelon form matrix. This is a row echelon form matrix. So we have to make sure the first non-zero element of a particular row. We have to first find out the first non-zero element of particular row. Okay. First non-zero element means this is the first non-zero element. Okay. The first non-zero element of a particular row, and then we have to check whether all the elements below that particular non-zero element, or whether the elements below the pivot elements are all zero or not. If they are all zero, then this is row echelon matrix. If they are not zero, then these are not echelon matrix. We have to make it. So let me do some another solution. I mean, not solution. Let me do some different example. So it's 2x minus 2y plus 3z equals to x plus 2y minus z equals to 3, and 3x minus y plus 2z equals to 1. And we have to solve this system of equation using Gauss elimination method. Okay. So what we have to do, we have to make it in a equals to b format, right? This is ax equals to b format. And then we have to find out, the next step is, so let me just mention it over here. This is A, this is B. Now we have to augment this A, augment B. That means 2 minus 2, 3, 2, 1, 2, minus 1, 3, 3, minus 1, 2, 1. Okay. So after augmenting, now the next approach is we need to do the row operation. Look, based on your intuition, you can do the row exchange. If you find out that the row exchange makes the computation complexity less, you can do that. But there is no need, because already we can see that the first element of the first row is non-zero. So we do not need to do that. And the calculation will be that much difficult. So we need to make this element, we need to make this element, we need to make this element and this element 0. For that case, we do the row operation. So the first thing is row 2 prime is row 2 minus half row 1. Okay. And row 3 prime equals to row 3 minus 3 by 2 row 1. So we are not changing the first row. So this is completely unchanged. The first element is 0. Okay. Half means minus 1. 2 minus 2 plus 1. This is giving us 3. And then half 3 by 2 plus 1. 5 by 2. And this is 2. 3 minus 1. 3 minus 1 is 2. Okay. And here 3 by 2. So this is 0. This is 3 by 2. This is basically 3 minus 3 minus 1 plus 3, giving us 2. And this is 3 by 2, 9 by 2. So 2 minus 9 by 2, we get minus 5 by 2. And this is 3. 1 minus 3, minus 2. Okay. Now we do the next operation. So next operation is basically needs to make this term to 0. Okay. So what is the next operation? It's R3 prime should be R3 minus 2 by 3 R2. 2 minus 2, 3, 2, 0, 3, minus 5 by 2, 2, 0, 0, 2 by 3. So it's 5 by 3. Yeah. We get 5 by 6. Then okay. So what is the solution? We get minus 5 by 6 z. So basically let me write down everything. 2x minus 2y plus 3z equals to 2. Then 3y minus 5 by 2z equals to 2. And lastly, minus 5 by 6z equals to minus 10 by 3. So that means what we get? We get, from the last equation, we get z equals to z equals to 4, right? So put z equals to 4, what we get? Y equals to, this is 4, that means 2, 10, 12. Y equals to 4. So if y equals to 4, z equals to 4, it would be 2 minus 12 plus 8 divided by 2 is minus 1. X equals to minus 1. So this is basically the answer of this equation. So as you can see, it is basically because after having this row echelon format, it is basically easier for us to find out the solution of this equation using the back substitution method, right? So that's why this echelon form is required. Now, okay, let me check another assignment, another questions. Okay, let's see, let's take this equation. So I have an example, something like that. I have an example, something like that. So it says, okay, so x plus by, b is basically the coefficient, is equals to 0, x minus 2y minus z equals to 0, and y plus z equals to 0. So it says that which number b leads latter to a row extreme. Let's try this. So first of all, we have to do this 1 b 0 x equals to b format, 1 minus 2 minus 1 and 0 1, 1. So here all the right hand, the B vector is basically 0. So we should not worry about these things. Okay. So here we do not need that A augment B. If you do, it's not wrong, but it's not required actually. It's basically not required. If you do this, it's not basically required. Okay. Now we have to find out the number B which leads latter to row exchange. So first we write the A matrix over here. We do not need any augment with B. And we do the row exchange. What row exchange we do? First row exchange we require is we need to change row 2 is row 2 minus row 1. Right? So what matrix we get? 1, B, 0. Here 0. This is row 2 minus row 1 minus 2 minus B. And this is minus 1. This is 0, 1, 1. Okay. So now the question is which number B leads later to row exchange? Now we can see here the catch is means like we have to find the value of B such that we need row exchange. We do not need any kind of scalar multiplication or subtraction with another row. We just extend the row and we will get the answer. So what value of B which leads us this? So we can see this is the pivot element of B, a pivot element of second row, right? This is basically the pivot element of second row. Now, if we make this element 0, so if we make minus 2 minus B equals to 0, which leads B equals to minus 2, right? If we choose this value of B, so what would be the solution? What would be the resultant matrix? 1, B, 0, 0, minus 1, 1, 1, right? So now we do not need any row exchange of, we do not need any kind of scalar multiplication and addition or subtraction. We can simply exchange the row, which is row 2 and row 3. We can simply exchange the row. So this is basically 1, B, 0, 0, 1, 1, and 0, 0, minus 1. So we get an echelon matrix. So value of B should be minus 2, which basically leads to the row exchange operation. Understand what the question means to you? Now, now the next question is of the same matrix. Same matrix, it says, next question is which B, that means which value of B leads, sorry, to a missing point. So I have to find out the value of B. So this will become minus 2. which B leads to a missing pivot. Sorry, missing point. It's not missing point, it's missing pivot. Okay. So missing pivot, what does missing pivot mean? So, so what was our equation? Matrix. After row echelon form, the matrix was 1B0, then 0, -2 minus B, 0, no, -1, and then lastly 0, 1, 1. So which B leads to a missing pivot, or rather I can say which B leads, I mean this missing pivot, what does this missing pivot means? When I'm saying that missing pivot, this missing pivot means like after that we have to choose a B something like that, so that after some row operation, one row is completely zero. That means there are, I mean, each row should have one pivot. If there is a one row there does not exist any pivot, that means all the elements are zero. That means missing pivot kind of scenario happens. Okay, so it is said like, so if we consider this -2 minus b equals to -1, consider, so what would be that value? So b equals to then -1. So if we choose b equals to -1, so what would be the matrix? 1 -1 0, 0 -1 -1, and 0 1 1. Now if we convert it into another, again we do the row operation because we need an echelon form. So what we have to do, it's we need to change row 3, that is row 3 plus row 2, right? And what we'll get? We get 1 0 0 -1 -1 0 0 -1 0. That means we get an this kind of format. That means there is a pivot element over here, there is a pivot element over here, there is a pivot element over here, but here the pivot element or non-zero element is missing, right? So here basically the non-zero element is basically missing. So that means if we choose the value of b equals to -1, we get this kind of scenario. That means we will not get any kind of pivot element. Okay. So if this is the scenario, let's say if this is the scenario, then what would be the solution? So if this is the scenario, if this is a scenario, then what would be the solution? That means x minus y equals to 0 equals to 0, then minus y minus z equals to 0. Okay, so that means we choose, if we choose z equals to 0, then there is only one solution, 0 0 0. but we are not going to choose z equals to 0. We have to choose some kind of non-zero solution. Because if we choose z equals to 0 over here, then we get y equals to 0, and put y equals to 0, we'll get x equals to 0. That means we get a zero solution. So we do not want this kind of thing. We want some kind of non-zero solution. Non-zero solution, let's say choose z equals to 1. Because we can choose z freely. There is no restriction on choosing z. So you can say you can choose y freely. You can choose y freely as well. But it is very efficient, or it is convenient to choose z freely. So from that z you will get y, from that y you will get x. Otherwise, if you choose y freely, then from that y you will get z and x. So like you will understand what I'm trying to say. So choose z equals to 1. So if z equals to 1, y equals to -1, and x equals to -1. Now if choose z equals to -1, y equals to 1, give x equals to 1. So any of the solution is right, because you will get a many solution. There is a condition, we will come up with that condition later, which signifies that a system of equation has many solution, not unique solution. Similarly, a similar example is over here. So the equation is something like that. System of equations are 2x plus 5y plus z equals to 0, 4x plus dy plus z equals to 2, and y plus minus z equals to 3. So similarly, the question is, which number d force a row exchange? So we need to find out the number. We need to find out the value of d, which basically force us to do the row exchange. Similarly, the previous one. Okay, but in the previous one, it was basically ax equals to 0 format, but here it is basically ax equals to b format. But because the b vector is not completely 0. So first of all, it's 2, 4, 0, 5, d 1, 1, 1, minus 1, x, y, z, 0 to 3. Okay, so yeah, now do the augment format. A augment b, we will get this 2, 4, 0, 5, d 1, 1, 1, minus 1, and then augment with 0 to 3. So what we do the row exchange. We do not sorry, we do the row operation, that is multiply with scalar, and then subtraction, that is row 2 minus 2 row 1, because we do not need any operation at first for row 3. So we will get 2, 5, 1, 0. Sorry, this should be 0, this should be d minus 10, and this should be 1 minus 2, that is minus 1. This should be 2. So here 0, 1, minus 1, 3. So similar pattern, we need that d should be something which force us to row exchange. So obviously, which force us to row exchange means we need to make sure that this term should be 0. So if we choose something like that, we will get d equals to 10. So what would be that result? It would be 2, 5, 1, then 0, then 0, 0, minus 1, 2, then 0, 1, minus 1, 3. After that, we need to exchange row. 2, 0, 0, 5, 1, 0, 1, minus 1, minus 1, 0, 3, 2. Okay. So value of d, it should be 10, which force us to exchange the row. Now that similarly, what should be the value of d? What should be the value of d? Such that there is no non-zero such that the system is inconsistent. So we have to do this. Let's say after row operation, we get this kind of structure. Oh, sorry, I think I have done a terrible mistake over here. No, no. Okay. So this is the matrix, and after row operation, row operation, we get this kind of thing. So what should be the value of d to make the system inconsistent? Let's say if we choose d equals to 11, because and then choose d equals to 11. So what we get? We get 2, 5, 1, 0, 1, minus 1, 0, 1, minus 1, and then 0, 2, 3. Right? Yeah. So now if we do the row operation, this R3 prime is basically R3 plus R3 minus R2 is basically 2, 0, 0, 5, 1, 0, 0, minus 1, 0, and here we get 1. So again, 0 equals to 1 format. That means system has no solution. Okay, system has no solution. So basically, this is basically the thing that we need to study. I mean, this is basically the whole concept of Gauss elimination echelon format. This is the thing. So I hope you have all understood what I'm trying to discuss over here. I hope you have all understood what are the format. You have all understood the questions and whatever I was trying to, or whatever I'm trying to deliver over here. I hope you all understand this. So on this note, I am uh, stop this uh, discussion for today. So today is basically we are talking about Gauss elimination method and echelon form, row echelon form, and we have seen that what are the benefits, what are the benefits of these procedures, what are the benefits of this procedure, and we will when we move to the next chapter, consecutive chapter, we will see that there are many more things. There are much more things which basically we are going to learn to know the linear algebra, to know the to solve the linear equations. There are in-depth knowledge about the linear systems. This is very important things to know further going. I mean, advanced criteria. Linear algebra is base of almost everything. So I hope you all get to know what I'm trying to say and what I tried to deliver. And thank you for today. And this is where I'm stopping my recording. Thanks for joining the class. Please tell me.
Sir, any question about permutation matrix and how to use the permutation matrix? That type of question.
Permutation matrix is basically it is basically used uh, just to exchange the rows. Okay, permutation matrix is basically used to exchange the row. I mean, what can I say? Like, let's say I want to exchange the first row with the third row. So what will be the permutation matrix? So here, this is basically, you can see here, this is basically I have already I have exchanged the row 2 to row 3. That row 2 and row 3 is basically exchanged. So that's why this is basically the permutation matrix for that case. Okay. I mean, is it clear
Thank you,
to
sir.
you? I mean, am I clear to you? Like what? So normally, when you multiply any matrix with the identity matrix, so this is basically an identity matrix, you will get the same matrix. But let's say you want, and you want the final matrix should be with some row exchange properties. Like if I have a matrix A and I multiplied with some kind of permutation matrix, I want that the resultant matrix, in resultant matrix, the row 2 and row 3 should be exchanged. So in that case, you have to multiply with these things. So how we will get this matrix, this row exchange, this permutation matrix is basically the identity matrix, and we exchange the row of this identity matrix. So this is basically the identity matrix. This is basically 1 0 0 0 1 0 0 0 1, right? And here basically we just exchange the row permutation matrix 0 8, sorry. So here we basically exchange the row permutation matrix is, let's say, 1 0 0 0 0 1 and 0 1 0. So just exchange the row of the identity matrix and multiply this exchange matrix with the A matrix and you will get that ultimate result. So this is basically how permutation matrix works. It's nothing but a exchange the row of ultimate that final matrix. Okay. Okay, I think this is clear to all.
Yes, sir. Thank you for
Yes.
the
Yes, sir.
fruitful interaction.
Yeah. Thank you.
Can we leave those who are done with
Yeah, yeah,
this?
yeah, 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 yeah. You can leave.
All
You
right.
can.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.